Hello friends, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy Karar, once again welcome you all to this my YouTube channel. In this video, we are going to discuss about the second part of this cycloalkanes, that methods of preparation of cycloalkanes. In previous video, we have covered with the different introductory part related to the cycloalkanes, means what is the meaning of cycloalkanes. Also we have covered how we are going to carry out the nomenclature of cycloalkanes. Also we have covered that which are the different members that are present in these cycloalkanes, difference between the cycloalkanes as well as our normal alkanes. So these are the various things that we have already discussed in previous video. If you have not watched my previous video, then you can watch it on this my YouTube channel, and if you like the content of this particular channel, then you can subscribe, share with your friends, and like my videos. So let's begin with our today's session. Now before beginning today's session, just we will see what are the learning outcomes of this our today's session. After this session, students will be able to explain the methods that are used for the preparation of the cycloalkanes. So just we will be discussing the different methods that are used for the preparation of the cycloalkanes. Now there are total 5 methods that are used for the preparation of the cycloalkanes. Now first method that is used for the preparation of the cycloalkanes is by means of the alpha omega elimination from dihalides. Dihalides means what? Halides, as we know, they are nothing but the compounds which are consisting of the halogens. Dihalides, that if there is a presence of 2 halogens in a given compound, then they are known as the dihalides. So just here the halogens that are present in the alpha and omega position of the alkane, if they are eliminated, means at the terminal carbon atoms, and then which leads into the formation of the carbon-carbon single covalent bond. Now alpha omega elimination from dihalides having halogen atoms on 2 ends of carbon chain with either sodium or the zinc dust give rise to the formation of cycloalkanes. The method can be regarded as intramolecular Wood reaction and is called as the Freund reaction. This can be used to prepare the cycloalkanes from 3 to 6 carbon atoms. Higher compounds, it is quite difficult to carry out the synthesis of these particular compounds. Now here just we can see the reaction that is involved in the synthesis of this particular cyclopropane. As I said that if there is a presence of the halogen atoms at the terminal carbon atoms with the help of the either sodium or zinc, when we carry out the heating of this into the ether, these halogens will combine with the sodium, and due to the loss of this halogen, these 2 carbon atoms will form the single new covalent bond, and which leads to the formation of our cyclopropane. Here means 1,3-dihalopropane will be converted into the cyclopropane. So here just we will be discussing only general methods that are used for the preparation of the cycloalkanes. We will be discussing the compounds like cyclopropane, cyclobutane, cyclohexane, any compound we can consider. Similarly, we can carry out the synthesis of butane, which is consisting of the 4 carbon atoms, by reacting it with the 1,4-dihalobutane. So in this way we can carry out the synthesis of the cycloalkanes with the help of this first method, that is the alpha omega elimination. This is the quite simple method, widely used, because just we have to remove the 2 halogen atoms from this particular alkanes. Now second method that is used for the preparation of the cycloalkanes is Clemmensen reduction. The reduction of cyclic ketones by zinc, amalgam and hydrochloride that is the hydrochloric acid, gives us a cycloalkanes. This method is called as the Clemmensen reduction. Basically, Clemmensen reduction means this method where generally if our compounds are consisting of cyclic ketones, then these cyclic ketones are converted into the alkanes. This is our method which is known as the Clemmensen reduction, which is applicable for aromatic compounds. Every compound means aliphatic compounds as well as the aromatic compounds. Just only condition that we require a cyclic ketone. Cyclic ketones are converted into the alkanes. Here we can see this particular reaction. Calcium adipate, which on heating in presence of loses the calcium carbonate, which leads into the formation of cyclopentanone. Actually, Clemmensen reduction reaction starts from here. Cyclopentanone, which is consisting of cycloketone, which on reaction with zinc amalgam in presence of hydrochloric acid, it will be converted into the alkane. So this is nothing but our Clemmensen reduction. So just cyclopentanone, how it is synthesized? It is synthesized by 2 moles of calcium adipate, which on heating loses a calcium carbonate, and there will be formation of cyclopentanone will takes place. So which is known as the cyclopentane. In this way, we can carry out the reduction of the cyclopentanone to get the cyclopentane, which is our cycloalkane. Likewise, here as we change this particular compound or this compound, we will get the different compounds which are present within the homologous series of this particular cyclopentane. Now, this is about the second method that is used for the preparation of the cycloalkane, that is the Clemmensen reduction. Now, third method that is used for the preparation of cycloalkanes is reaction between alkenes and methylene iodide. Alkenes on treatment with the methylene iodide, that is the CH2I2, in presence of zinc, copper couple, or by diazomethane, that is the CH2N2, in presence of the UV light, gives us a derivatives of the cycloalkanes. So this is also one of the important as well as the very simple method is there, in which we will be treating alkenes. Alkenes, as we know, they are the derivatives of alkanes with the double bonds that are present between the 2 carbon atoms. Here we have taken the example of propene. Propene, as it is consisting, one propene means what? Here the double bond is present between the first and the second carbon atom. So one propene in presence of methylene iodide, in presence of the zinc and copper as a catalyst, leads into the formation of the derivatives of cycloalkanes. So here you can see the methyl cyclopropane is formed, because here whatever this methyl group is there, it will be gets attached to one of the carbon atom of this propene, and due to which there will be formation of derivative of cycloalkane will takes place. Similarly, 2-butene means what? Here the butene, it stands for the 4 carbon atoms, and 2 it stands for the double bond that is present between the second and fourth carbon atom. So this butene on a similar reaction with methylene iodide in presence of zinc and the copper, it will leads into the formation of the dimethyl propane. Means in this way we can carry out the generation of the different derivatives, cycloalkanes derivatives, with the help of the changing the initial alkene that we are going to use. In this way, this method is also suitable, which can be performed in presence of UV light to give the derivatives of cycloalkanes. This method is also widely used to carry out the synthesis of different cycloalkane derivatives. Now, fourth method which is used for the preparation of cycloalkanes is by using Dieckmann cyclization method. This method is also a common method that is used for the synthesis of the cycloalkanes, in which esters of dicarboxylic compounds or dicarboxylic acids on heating in presence of sodium ethoxide undergo intramolecular Clemmensen condensation reaction to give a cyclic beta keto ester. These beta keto esters on hydrolysis and subsequent heating give cyclic ketones, which are reduced with the help of the zinc amalgam and hydrochloride to give a cycloalkanes. Here, just if you remember, just what we are going to do, cyclic ketones are converted into the cycloalkanes. Already we have seen this particular reaction, that is the Clemmensen reduction, where cyclic ketones are converted into the cycloalkanes. So this one is also one of the important reaction where first esters of dicarboxylic acids, they are heated in presence of sodium ethoxide, which undergo the intramolecular Clemmensen condensation reaction to give a cyclic beta keto esters. And these beta keto esters on hydrolysis and heating, they will be converted into the cyclic ketones. Now just we will see what is the reaction. Here we are taking the example of diethyl adipate as a ester of the dicarboxylic acid. This ester of dicarboxylic acid, which on heating with the sodium ethoxide, first it will be converted into the cyclic ketone. This cyclic ketone again further on hydrolysis, it will be converted into the ester is converted into the dicarboxylic acid and beta keto ester. Here you can see beta keto ester means what? Here already there is a presence of the ketone functional group. This is known as the beta keto carboxylic acid compound or the esters. This beta keto ester on treatment with the zinc amalgam, they will be converted into our cycloalkane, that is the cyclopentane will be formed. So this is the another important method, that is the Dieckmann cyclization method, which can be used for the preparation of the cycloalkanes. Then last method that is used for the preparation of the cycloalkanes is from aromatic compounds. Generally, 6-membered cycloalkanes can be easily obtained by the catalytic reduction of benzene and its derivatives like phenol, which on catalytic reduction first gives the cyclohexanol, which on further treatment with zinc dust gives a cyclohexane. Means there are number of ways are there by which we can carry out the preparation of cyclohexane. Cyclohexane is nothing but it's a 6-membered cycloalkane. First and common method that is used for the preparation of cyclohexane is from the benzene. So benzene on catalytic reduction, that is the reaction in presence of the hydrogen, that is the hydrogenation reaction in presence of a nickel as a catalyst at 200 degrees Celsius, it will be converted into the cyclohexane. Similarly, cyclohexanes can be prepared from the different phenolic compounds. Like here you can see, first phenols are reacted with the hydrogen so that whatever these double bonds are there, unsaturated compound is there, it will be converted into the saturated compound, that is the catalytic hydrogenation is again carried out. Now here cyclohexanol that we have got, this cyclohexanol, now we have to remove this hydroxyl group. In order to remove this hydroxyl group, we need to carry out the treatment of cyclohexanol with the zinc dust, which leads into the formation of cyclohexane. So these are the various methods that are used for the preparation of the cycloalkanes. Thank you. If you have any queries related to this particular pharmaceutical organic chemistry, then you can contact me on this particular my mail ID shahavishalvi99@gmail.com. And if you like the content of this video, then please like my videos, share and subscribe to my YouTube channel. Thank you.